This is a physical computer which I've been using for quite a while to run virtual machines on, and at times I've been using VMware ESX and then moved over to VMware ESXi as a bare metal hypervisor. So I've been running virtual machines for studying and proof of concept testing, and the reason I can do that is because this particular computer that I've got is, although it's not actually a dedicated physical server like an HP or a Dell, it's got an Intel i7 processor, so it's got 4 cores which with hyperthreading give me 8 logical processors. It'll support up to 24 gig of memory, so as you can see I've maxed that out, and that's great for being able to run several virtual machines on it. And what I've also done is I've removed the original high-end graphics card and replaced it with a smaller fanless graphics card, and I've also replaced the high-end power supply unit with a hybrid modular power supply unit, and by doing that it's allowed me to reduce the actual energy footprint of this particular machine. It consumes less power, which is ideal because it'll be running for quite long periods usually when I'm running virtual machines on it. I've also had to install Intel Pro network cards into it, because when I first started using VMware, although this motherboard that I've got on this computer has built-in Marvel network cards, they weren't supported by the VMware operating system, and there weren't any drivers available to take advantage of them at the time either. Now over time I've found you can actually get drivers for those network cards, and if I wanted to I could actually take advantage of them. I mean, I've even installed the drivers to test them out and do work, but because I've already got these 2 Intel Pro network cards in this machine, and they work straight out of the box. I mean, they're supported by the VMware operating system by default. There's not really a great need to make use of those Marvel network cards, because it's just a test lab and 2 network cards are enough really. So what I've done for this machine here is it's got 2 hard drives. One's the one that has the operating system, the ESXi operating system on, and the other one I'm using just basically for storage. So I'll create the virtual machines on this particular hard drive, and I'll use it to provide storage for a virtual SAN that I'll create on this as well. The actual boot disk, as I've named it here, it's actually a Western Digital Raptor hard drive, so it is slightly faster than most mechanical drives, but obviously I can improve the performance of both of these much more if I used SSDs or if I used RAID arrays, for instance. But again, it's just a lab that I'm creating here, so just running these 2 hard drives is enough for the moment. I've also got, as I mentioned, two physical network cards configured on this physical computer. These are patched into a physical switch which supports .1Q trunking, so I can actually configure trunks on these switch ports. But the switch itself is it's a low power switch that I've purchased, and what that allows me to do is to leave this computer powered off, and then when I need to use it, especially if it's going to be used remotely, I can log into the network remotely, send a wake on LAN packet to the actual computer. The network card will pick that up, and then the computer will power up, and then once I've finished using the actual computer, I can then just shut it down remotely and save power. So apart from the physical changes that I've mentioned there, whether I'm going to be using ESXi 5.0 or 5.1 as the operating system, the configuration for the networking is always the same. So I've got, as I say, 2 network cards here, both patched into switch ports which have been configured as trunks, and that allows me to pass any VLAN backwards and forwards between the physical network and the virtual network. I've got a virtual machine port group here which has been called storage, and that's attached to VLAN 11, which is what I'm using for the storage network. For the virtual SAN that I create, I'll give that network connectivity into this storage port group, and that allows me to connect the virtual hosts to the SAN through VLAN 11, and then take advantage of, say, iSCSI or NFS to provide them with their network storage. For the management port group here, the VM kernel that's used for remote management of this physical computer, I've put that into VLAN 10, which is my network management VLAN for this particular lab. And I've also created a corresponding virtual machine port group in VLAN 10 and called it management. So if I've got a virtual machine on this physical computer, I'll give it network connectivity into this port group. So the SAN, for instance, that I create as a virtual machine will have a network card in here, and that allows me to get remote access to the that SAN and configure it. I've got another port group configured here which I've called trunk, and I've assigned that to VLAN 4095, which for a standard switch means basically all VLANs. And the reason I've done that is that the virtual hosts that I create will have their network cards connected to this port group. All of the network cards will be in here, both for simplicity and to allow me to test out different design strategies for the network cards that they have. In, for instance, what I could have is I could have two network cards that are patched into a virtual switch on the virtual host that patch into this port group. And then what I could do is I could create VM kernel ports on those on that virtual switch, one for, say, vMotion and one for fault tolerance. I'll be able to assign one of those network cards to vMotion as the active network card, and the other one will be its standard. And then on the flip side, I'll have one of the network cards will be the active for the fault tolerance, but will be the standby for vMotion. So that allows me to test out failover features like you can do in the physical network, and that's only possible by having these network cards patched into the actual trunk port group here. If it had been assigned to an actual port group which had been configured for a specific VLAN for vMotion, then you wouldn't be able to use that for fault tolerance as well. So another reason that I put all the network cards into this trunk port group is that it also allows me to provide the actual virtual machines that run on the virtual hosts with access to any VLAN that's on the network. So for instance, if I've got a physical computer which is in VLAN 50, it'll be able to get access to a virtual machine running on one of the virtual hosts in VLAN 50. But in order to do that, I do have to make an actual configuration change to the virtual switch. I have to change the promiscuous mode here from reject to accept. If that's set to reject, then a physical computer, for instance, would be able to get access to a virtual machine running on the actual physical computer itself, because that will be connected directly to this virtual switch. But it wouldn't be able to get access to one of the nested virtual machines running on one of the actual virtual hosts. So I do have to actually set the promiscuous mode to accept to be able to allow traffic to pass from the physical network to a nested virtual machine on a virtual host. So once I've made those changes to the virtual network here, as I say, those changes will be the same whether I'll be running ESXi 5.0 or 5.1. But if I want to create virtual hosts on this physical machine and it's running 5.0, I've actually got to make a configuration change to the computer here in order to allow that feature. Now, the change that I've got to actually make is to add that particular line there, that parameter, if you will, to this configuration file. There are different ways that I can do that, but one is to start the SSH service up, because by default it's turned off. And then once I do that, I can then remotely log into this computer through SSH. Now, to add that extra parameter onto the configuration of the actual physical computer, I could use var, for instance, and just add the line at the end of the config. But the easiest way and the most common way you'll see on the different internet websites that tell you how to set up virtual hosts or nested virtual hosts, they just use this echo command to redirect the output to the actual configuration file. So I'll just copy that command, I'll run that, and then if you run that cat command for the configuration file, I've got that parameter now added on to the configuration file, and having done that, the computer will now it'll now actually allow virtualized hardware virtualization on the virtual machines that I create, which is what I need to create these virtual hosts. I will have to make some changes to the actual virtual hosts themselves later on, but if I'm going to run version 5.1 of ESXi, I don't need to make a change to the actual physical computer, but I do have to make some configuration changes to the virtual host to enable that feature. That's because in 5.0 this feature is being decided more or less by the actual physical computer, whereas in 5.1 it's something you're deciding on the actual virtual host. So having made that change, I can then actually start creating virtual machines and installing the bare metal hypervisors into it if I wanted to. And that's about as much as I'll do for this physical computer, other than installing virtual machines on it as virtual hosts, because I want to keep a sort of like an extra layer of abstraction here as far as this computer goes. I want this computer to be really kind of transparent in effect. Any virtual machine that I create on this computer, I want to treat it as if it is an actual physical computer. So I'll have, for instance, some virtual hosts on here which are going to be treated as normal hosts within vCenter. I'll create a virtual machine on here which runs an actual virtual SAN, but I'll be treating it as a physical SAN as far as the virtual hosts are concerned. So once I've configured that actual physical computer, added in my virtual hosts and virtual SAN, I don't need to make any additional changes to it really. That's as far as I need to go. All additional work would be done on the actual virtual hosts or the virtual SAN.